Hi guys, so here we have a interesting E&M problem. So we have a circuit with a bunch of branches. It looks weird, but anyhow, we know that the ammeter in this specific branch right here, it reads, give me a second, gotta switch colors. It reads 4 amperes, and the voltmeter specifically connected to this resistor reads 5 volts, and we want to find the EMF and the resistance R. We'll start by finding the resistance R because it's easier to solve for that first and then go for the EMF. So we start with finding the current through this resistor. The reasoning behind that is that if you know the current going through this guy, then the current going through this other resistor is the same. And why is that? Because these two resistors are actually in series. So the same current, what I'm trying to say is the same current flows through these two resistors. So we start with writing down Ohm's law, V is equal to IR. We rearrange for the current. We know the voltage on this 2 ohm resistor is 5 volts. So that's 5 volts over R, which is the resistance of this guy, so 2 ohms. So yeah, we get 5 over 2, which would be, in decimal form, would be 2.5 amperes of current. Sorry, that was weird. Anyways, here we go. So yeah, 2.5 amperes. That's awesome. So we have 2.5 amperes of current flowing here. That's great. Now I need to try to find the voltage on this guy. And here's why. If I find the voltage on this guy, I can add up the voltage of both of these resistors, and that gives me the voltage across this entire branch. And the advantage with knowing the voltage across this entire branch is that it'll essentially, the voltage is going to be the same on this branch or on this branch. Whatever is parallel will always have the same voltage. That's what I'm trying to say. We're going to use Ohm's law again on this 4 ohm resistor to find its voltage. So the voltage on this 4 ohm resistor, I'll label it for you, is IR. The current is the same as before, and what we're really trying to solve for now is 2.5 amperes times R, which is 4 ohms in this case. So 4 times 2.5, I'll plug that into my calculator. That gives me 10 volts. Okay, so the voltage on this guy is 10 volts, and the voltage on this guy is what was it again? Oh yeah, 5 volts. Awesome. So now I can add up these voltages and find the voltage in a single branch. I'll call it V branch. So I'm saying voltage of the 2 ohm resistor plus the voltage of the 4 ohm resistor, which is going to be equal to 5 volts plus 10 volts. That gives me a total of 15 volts in a single branch. So what I'm trying to say is I'll have, since this branch is parallel, let me relabel that. Since this branch, this entire thing here, sorry for the horrible coding, is 15 volts and it's parallel to this entire branch, then I know that the voltage on this entire branch is also 15 volts. And the same goes for here, and the same goes for here. Now to kind of move on to the resistance, to find this resistance, Give me a second. So yeah, we know that the ammeter reads, I'll get rid of that. We know that the ammeter reads 4 amperes and the current flows from high to low, positive to negative on the ammeter essentially. So I'm going to assume the current is going this way. It really doesn't matter if the current happens to have a negative value, like whatever. It just means that the current was actually flowing in the opposite direction. This applies for any other question. So that's 4 amperes. So again, we do the same thing. We know the total voltage across this entire branch. And the ammeter, it's not really taking any voltage on it. It has essentially an infinite resistance. Wait, no, hold on. Actually, yeah, I'm wrong. So the ammeter has 0 resistance, that's what we assume. So it's not really taking any voltage on itself. So the only other component left in this branch is this resistor here, this guy. So the entire 12 volts is on this resistor. That's what we're trying to say. So now we will have to use Ohm's law again. To find the resistance of this guy, basically. So rearrange. So we have VR over I. Yeah, so the voltage is 12 volts, and we're dividing that by 4 amperes. Okay. That is going to give us 3 ohms, and let me double check. Okay, so I've messed this up somehow. Why is it 3.75? Did I get the question wrong? Whatever.